So today I'll be showing you how to solve simultaneous equations. There are two methods, the subtraction method and the substitution method. So let's start off with the subtraction method. Here's an example. 3x plus 2y is equal to 3, and 2x plus y is equal to 1. Okay, so in order to be able to subtract these, we need to have a common coefficient for one of the variables, either x or y. And here you can see that we have 2y in the top expression. So we can multiply the bottom expression by 2, right? We can multiply everything here by 2 in order to get 2y on the bottom, so that we can also subtract, so that then we can subtract the expressions. So when we multiply the bottom, we get 4x plus 2y is equal to 2. And then the top stays the same, so we get 3x plus 2y is equal to 3. So now we can subtract this, so 3x minus 4x is equal to minus x, 2y minus 2y is equal to 0, and 3 minus 2 is equal to 1. So if minus x is equal to 1, we get the inverse of this, and so x is equal to minus 1. Okay, and now that we have x, we can plug it back into the expression, either one, because it's going to give us the same answer, and we'll get y. So let's do that. So 3 times minus 1 plus 2y is equal to 3. Simplifying that down, we get minus 3 plus 2y is equal to 3. And now, if we just finish tidying that up, we get 2y is equal to 6, and y is equal to 3. Okay, so that's good. Now let's try the substitution method. Let's take another example. So we have x plus y is equal to 4, and 3x plus 2y is equal to 20. Okay, so what substitution means is that we can get either x or y in terms of x or y. So we can get x in terms of y or y in terms of x, and then we'll plug that into the other expression and we can solve for the variable. So here's what I mean. Let's take the top expression and rearrange it to get x in terms of y. So if we did that, we would get x is equal to 4 minus y. And now that we have that, we can plug it in to this expression. So let's do that. So instead of x, we will put 3 times 4 minus y plus 2y is equal to 20. So now let's multiply that out. So 12 minus 3y plus 2y is equal to 20. So tidying up, we get 12 minus y is equal to 20, which means that minus y is equal to 20 minus 12, which is 8, and thus we get the inverse of that, so we get y is equal to minus 8. Okay, so those were two simple examples, but you can always get problems that are a bit more difficult. So they can ask you, find the point of intersection of the lines, for example, of the lines y minus 2x is equal to 1, and y plus x is equal to 4. So if they ask you to find the point of intersection between these two lines, that simply means use simultaneous equations. So here it's already laid out for us that we can use the subtraction method because the coefficients on y are the same for both expressions. So we'll subtract it. We'll subtract the top from the bottom. So we'll do y minus y is 0, minus 2x minus x is minus 3x, and 1 minus 4 is minus 3. So x is equal to 1, and as before, we'll plug that into one of the expressions. So I'll just plug it into the bottom expression, and we'll get y plus 1 is equal to 4, and so y is equal to 3. And so the point of intersection is going to be x comma y, so that's 1 comma 3. And we can prove this by actually graphing the same problem on a graph. So let's try that. I'm just going to make a makeshift graph here. So here's the y-axis, here's the x-axis. So we'll start at 0, 1, 2, 3, 4. So just 1, 2, 3, 4. Same here, 1, 2, 3, 4. So 1, 2, 3, 4. Okay, perfect. So now let's look at the lines that we were given before which were y minus 2x is equal to 1, and y plus x is equal to 4. Now if we arrange those to be the same as the formula of a line, so that we can graph it, we will get y is equal to 2x plus 1, and here we will get y is equal to minus x plus 4. So now we can graph that. Let's graph the top one first. So if the y-intercept is 1, if you're confused about this, check out our video on the line. So here the y-intercept is 1, and then the slope is going to be 2 over 1, so that's going to be going up 2 and over 1. So this is going to be our slope. Here we go. Okay, and then for the bottom one, we'll do the same thing. The y-intercept is 4, and the slope is minus 1 over 1. So that'll be here, and here, and here. So now let's just draw the line. Okay, so now we can see that the point of intersection here is 1, 3. And something interesting is that that's exactly what we got when we used simultaneous equations. So that's it. Now you know how to solve simultaneous equations using subtraction and substitution.